Hey, welcome to Analog Output. I wanted to show you how I make power cables for synthesizer modules. This is a typical Eurorack power cable. It's got a 10 conductor ribbon cable with a 10 pin connector on one end, 16 pins on the other. Most Eurorack modules these days use a 10-pin header on the module circuit board, so you use this style of connector. You sometimes find a few modules that still use the 16-pin header on the module, and usually a distribution board has 16-pin headers, so then you'd have a cable with 16 conductor ribbon cable with 16-pin connectors on both ends. But the 10 and 16 is what you find more commonly. For the Kosmo format that I tend to build in, it's always 10-pin connector on the module, and I've lately been using distribution boards that also have 10-pin connectors. So I've been using cables like these that are 10 conductor with 10-pin connectors on both ends. And they all go together the same way. So thought I'd show you that. The first thing to ask, of course, is why would you make your own cables? Can't you just buy them? And of course you can. There are sources online and a few brick and mortar places where you can actually buy Eurorack power cables. They'll sell you the 10 connector and 16 ones, or the 16 and 16, and some places will have the 10 and 10 ones. And they're pretty inexpensive. You know, a cable like this one will probably cost you about like 89 cents. So if you think maybe making cables will save you money, well, axiomatically it'll save you no more than 89 cents per cable, which is nothing to get particularly excited about. I mean, yeah, you can get the parts for less than 89 cents, but not that much less. But there's a couple reasons why you might want to make your own cables anyway. One is, let's suppose you've just finished building a module and you go to hook it up and you discover you don't have any more cables of the right number of connectors and the right length and so forth. What do? Do you log in on your computer or your phone and make an order and sit and wait for a week before you can connect up this module? Or do you disconnect another module in your system so you can connect that one? Well, there's a good chance you do, but wouldn't it be nice to just have the right cable in your hands 5 minutes from now because you've got the materials and the tools to do it? Or another thing is you might go log in to buy these cables and discover that they're out of stock. This has happened to me. It's what led me, in fact, to building cables in the first place. And this happens a lot of the time. I've noticed you go to the page where you order cables and you find they have like a dozen kinds of lengths and number of connectors available, except that half of them are out of stock at any given time. I don't know why, but that's the way it is. So, a third reason is maybe you want something that's not something easily available as a standard thing. Maybe you need a really long cable for some reason, or maybe you need a cable with not 10 or 16, but some other number of conductors and pins on it. I'm working on a module now. I hope you'll see it in the not terribly distant future that has two boards that are connected by a 14 conductor ribbon cable with 14 pin connectors. Good luck trying to buy that, but you make them just the same way. So knowing how to do these things, it's a useful thing. So how do you make these things? Well, you need some raw materials. You need some cable, and you need some connectors. Here's Can you see that? There we go. There's a 10-pin connector in its various pieces. I got a 16-pin one here, and you need some tools. You need to be able to cut the cable, so I use these. These are, wire strippers and cutters, and you need a way to put the cable together. And for that, it is possible to use pliers. I don't recommend it. It's not a tool for the job. It's not very easy or practical to use, but if it's all you've got and you really need the cable, you can give it a shot. Give it a try. Another possibility for a tool is a bench vise, and that works very well. I've built lots of cables using a bench vise. The only problem with the bench vise, as far as I'm concerned, is it's on my bench, in my workshop, in my garage, in the middle of upstate New York, which in the middle of winter gets very cold, and going out there and freezing your fingers off just to make a cable is not a very appealing thing. So I got one of these. This is a tool specifically made for the job. It's cost me about $15 on Amazon, and it keeps my fingers warm, and I like it a lot. I'm going to have a link down there in the description to a page where you can find several different sources for all of these things, the cables, the connectors, the tools. Check that out if you want to figure out where to go to get all these things. So let's make a cable. First thing is cut the wire, figure out what length you need, and cut it a little bit longer than that. We'll make one about, let's see, about that long. Okay, now got that. Now we've got to get our connector. I'm going to take this thing, and this has this yellow piece here which slides out. And the yellow piece, you see, has a couple of notches in it. The connector has three parts. There's this part, that part, and the other part, to give them their technical names. And this is the bottom part, and you notice it has a tab kind of a thing on one side. So that goes into this thing. Press it in with that tab sticking into the notch, and it can be a little stubborn getting it in there, but it'll go. So we got that in there. Okay. These two pieces look kind of similar, but one of them is a little bit wider, and it's got, wider ears with big holes. This has got narrow ears with no holes. You take the one with the wider ears, and that goes into this piece right here. Okay, you don't push it all the way down because the ribbon has to go into here. Now this is where you have to pay attention. First of all, though, I'm going to put this back in the tool. By the way, it is possible to get this connector stuck into this yellow piece without removing the piece from the tool. You can just put it in here. It's kind of awkward, but if it works for you, that's fine. Doesn't matter. Okay, we've got this in place. We've got the tab on the top here. And so that means the cable is going to go in with the red stripe, showing it to you from my point of view, with a red stripe on my right as I look at it. The electrons don't care what color the wire insulation is, but the electrons do care if you've crossed over what should be the connector for the positive side with the connector that should be for the negative side on the other end, so that you connect your positive source to your negative pin and vice versa. That causes severe pain and anguish. So you use the red stripe to keep track of what's going on, and you try not to let it fall out like that. I'll put it back in again. Anyway, making sure the red stripe is on the right when the tab is on the top. And this thing only has to come through just enough for you to see that it has come through. It doesn't have to stick out really at all. Doesn't hurt if it sticks out a little bit. Okay, so we put it through, and then we just press down on that, and that clamps down very nicely. And I will pull the yellow piece out again, and there we have these two pieces of the connector on here. Okay, now take the ribbon, fold it over, take your third piece, the one with the narrow ears, and then just put that into place. Fingers, press it down until it clicks. Okay, this is your strain relief. It gives you something to hold on to, and keeps the ribbon from pulling loose if you put too much tension on it. Where'd that other ribbon go? There it is. This is a ribbon that I bought online commercially, and they made it without the strain relief. It's just the two pieces. They just didn't bother with the strain relief pieces, I guess. I don't know why. Don't be that person. Use the strain relief. It's a good thing. It keeps your cables from falling apart at times when they shouldn't be falling apart. Okay, let's put the other end on. It's going to go the same way. This is a 16-pin connector. We're going to put it into the yellow piece. It's in place. The tab is on this side. We're putting this piece with the ears with the holes in place. Okay, and then we'll stick that into the tool. Okay, and so we've got the tab on the top here, and the ribbon cable is going to go in with the red stripe on the right. Now, here, the cable is narrower than the connector, so it could be anywhere left and right. It should be as far as it can be to the right side. So, oops. Let's get that open there. Alright. Get that in all the way over on the right. Make sure it's coming through. And then we will clamp down. Okay, yellow piece comes out. Cable comes out. Strain relief will go in. You need to fold this thing over first. Strain relief goes in until it clicks, and we've got our cable. Okay, now one thing you might be concerned about, and it was certainly a concern to me before I started making these things, is, well, these things are power cables. They're carrying the power to the system, and if you make the cable wrong, bad things can happen. Is that something to worry about? Something to be concerned about. But I point out it's something you should be concerned about with ribbon cable, power cables, anytime, whether you made them or not. Even if you bought them online, just because you bought them from someplace that's charging money for them, doesn't mean they're perfect. Doesn't mean that they were made without a flaw. And people have been known to buy cables online and use them and find they're shorted or they're not connecting or something's wrong with them. And before you entrust your multi-$100 Eurorack module to a cable, you really ought to make sure that cable is good. So there's a couple ways you can do that. One is you can take a multimeter and start checking, is this connected to this? Is this connected to that? Are all the things that are supposed to be connected? Are all the things that are supposed to be not connected? You know, is this conductor there connecting to the conductor next to it, which it should not be? Things like that. You can do that with a multimeter. It's going to take some time. It's fairly tedious sort of a thing. There is a better way. So at some point I discovered on GitHub a repository. There's a guy named Tommy Van Leeuwen, or I'm not sure of the pronunciation, but they made an electronic circuit that is a power cable ribbon tester. Power ribbon cable ribbon power. It's a tester for power cables. And they have the schematic there, and then they have a picture of the one they built, without a lot of details about the layout of how they build it. It's built on some sort of a proto board, strip board, something, I don't know what. I couldn't really tell how it went together, but they had the schematic for it. And so I decided to fork that repository and make a PCB layout for the same circuit, so I could make my own on a PCB. And here is the result. This is a cable tester, and the way it works is this. Okay, so here is our cable tester. It's powered by a little Nano microcontroller here. We'll plug that in on a USB power cable, and this little OLED display lights up and says no cable. Well, okay, let's give it a cable. So there's 16 pins, 10, 16, 10. You use whichever one to whichever one you need, and I'll put a 10 and a 10 in there, and the LED says cable OK. And if you look at the details, it says the -12 is OK, the ground 1 is OK, ground 2, ground 3, +12, and the other 3 it says nothing because they're not there. So immediately you know this cable is OK. Let me show you what would happen if there were a short. I can simulate that just by sticking a screwdriver in over here, and it says shorted, and it tells you which conductors have the short between them. So if there were conductors that were not connecting from one end to the other, it would tell you that as well. Takes a lot less time, a lot less trouble than trying to use a multimeter to check all these things. Give you confidence that you've got this thing done correctly. If you want to make one of these things, there's a link to the GitHub repository below. You can work up a strip board layout if you want to do it that way. If you want to do it on a PC board, you can download the Gerber files and upload them to have them fabricated. You can probably get 5 of these boards made and shipped to the United States for as little as probably about $10 or $12 or something like that. You can spend a couple dollars to get the microcontroller, a couple more dollars to get the OLED, a few cents more for the various other parts. This is a multiplexer chip, and then there's just some resistors, connectors, capacitor. So, you know, $15 or so, you can make one of these things, and you'd still have 4 leftover circuit boards, which you could sell to your friends if you've got friends who also want to test cables, and reduce the cost to yourself a little bit that way. But it's cheap insurance to give you peace of mind that your cables, whether they were cables you made yourself or cables that you bought, are actually good and not going to cause tremendous destruction when you try to plug them in. So there you are. That's how you make ribbon cable power connectors for your Kosmo or Eurorack synthesizer modules. Hope you enjoyed that. Hope you learned something from it. And check out the links below again for sources for where to get these things and how to make yourself one of those cable testers. If you enjoyed this, please hit the like button and where is it? Over there, I guess. And, subscribe, and you'll get a notification next time we've got a video coming up, which I hope will be soon. And I'll see you then next time on Analog Output.